Alright, now we have some applications of right triangles dealing with this trigonometry unit. So here, for number 1, solve for the right triangle ABC below, with C as being equal to 25 degrees and A as being equal to 13.2 inches. So remember, the uppercase letters represent the angles, so that means this angle for C is the 25 degrees. And the side A here, lowercase a, because it is opposite of angle A, which means that lowercase b would be opposite of angle B, and lowercase c would be opposite of our angle C. So remember that whenever this stuff is not necessarily always labeled, and the triangle may or may not already be given to you depending on the problem. So keep that in mind whenever you're setting up these triangles and you're trying to draw it out to help visualize that you are getting those angles and sides labeled correctly. So here in this case, if we have this 25-degree angle, that means our side C in this case is the opposite side. So we'll put OPP for the opposite side. And our side A here is our adjacent side. So we'll put ADJ for adjacent. And our side B here would be what's called our hypotenuse. So here in this case, one way of setting this up is to use this acronym of SOHCAHTOA to help figure out whether we want to use the sine, cosine, or tangent function here. So remember, S represents your sine, which is your opposite over hypotenuse. Cosine is the C, which is adjacent over hypotenuse. And your tangent is your opposite over adjacent. That's what those letters represent again. So in this case, we don't know the opposite side here, but we do know the adjacent side in this case. That is 13.2 inches. So here in this case, we can use the tangent of 25 degrees. It's always got to be with the angle measurement for your sine, cosine, or tangent, is equal to the opposite side, which was our side C, divided by the adjacent side, which was 13.2. And then we can multiply both sides by 13.2 to get it out of the denominator. And once again, there are multiple ways to do this. This is one way of setting it up. And make sure again that your mode is in terms of degrees, otherwise you're going to get a totally different answer for these. So here for your C, remember this is for lowercase side C, you get about 6.16, and that would be in terms of inches since it is one of our sides of the triangle. And then to figure out our side B, we can do something similar, but in this case, we would have our adjacent side, once again, we know, and our hypotenuse is what we're trying to solve for. So we could go ahead and use our cosine of 25 degrees is equal to our adjacent, which was the 13.2, over the hypotenuse, which is our side B. So again, since you already know what your side C is, you could have also used sine instead if you wanted to, and use that 6.16 that you just got for C would have been another possibility here. But we will stick with this way. So in this case, we would need to multiply both sides by B to get it out of the denominator. So then we'd have our B times cosine of 25 degrees is equal to that 13.2. And then divide both sides by that cosine of 25 degrees to finish getting B by itself. So then for your side B here, if you go through and do that 13.2 divided by the cosine of 25, you should get about 14.2 0.56. Once again, it is in inches since it's another side of the triangle. So now we have what side C is and what side B is, and we already knew side A. And we know what our angle B is since we have that it's a right angle. That's what this little box in that corner means, that it's a right angle. It's a 90-degree angle. And we had angle C was given to us was that 25-degree angle. So only part of this triangle left to solve for is our angle A, which remember all the angles inside of a triangle have to add up to a total of 180 degrees. So to figure out our angle A, you could do 180 minus the two angles that you already know, the 90-degree angle and the 25-degree angle. So for our angle A here, you should end up with 65 degrees. Yeah, write that a little bit better for you here. 65 degrees would be your angle A. So whenever you go through, if you were to check this, you want to make sure that all those angles add up to 180 degrees. And if you were to check your sides, you should be able to use that Pythagorean theorem to check to make sure that those sides do in fact work for that right triangle. And make sure if you do have questions on this to ask, and we will do number 2 in the next video.